Hey, good morning, everybody. This is Mr. Ainsworth, and we're going to get into your Section 2 homework here in Unit 5 here in AP Pre-Calc here at Great Oak High School. So let's get on it. All right, so here we go. The function t equals f of s represents the number of school buses t, all right, needed to transport s students. So far I know that the domain, the input is students. So s is students because it says so. Right here in the function t, which is f of s, is the number of buses. All right, so your function represents number of buses. And so you want to make sure you understand your variables before you do any interpretation, because it says interpret the meaning, all right, of this function, this inverse function. This is f inverse of 33, gives you 650. What does it mean? Okay, so first of all, let me just restate the inverse here. Because you should be able to go from inverse back to regular function at any time. And so you can interpret it, a little bit easier. Okay, so if it tells you that f inverse of 33 is equal to 650, all right, that tells you that f of 650, all right, is equal to 33. These are synonymous. They mean the same thing. All right. Conceptually speaking, here, what's going on is that in the domain of the function, okay, we have 650 here. The domain is the number of students, as it says so, number of students. This is s, okay? It says so. And then the function, all right, f takes it, you put 650 students in, figure out how many school buses you need. So the number of school buses depends on the number of students. So the range here, the output, represents the number of buses in general. Okay, how many buses are needed, given 650 kids? And so it says there are 33 buses needed. Okay, well, the inverse takes you right back, all right? F inverse takes 33 buses and it says, okay, well, we need 600, or it depends on, or is determined by 650 students. So the meaning of this is pretty simple. It takes 33 buses, okay? This is buses now. And this right here is students. So it takes 33 buses to transport 650 students. So let's write that out. It takes, all right, 33 buses to transport, all right, 650 students. There we go, and there's what's called the interpretation. We do a lot of that in this class, as you guys know. I mean, everything's in a context, and you have to interpret everything, and everything means something, all right, because everything's put into a context. Okay, number 2, f of x is equal to negative 1/3 x plus 11 is a linear function. Okay, write the function g, the inverse of f. I don't know why they say that. Just basically, we have to find f inverse. Okay, so find the inverse of f, which is written like this, f inverse. Okay, so I don't know why they say call it g when the inverse of f is called f inverse. Okay, that doesn't really kind of make sense. So what we're going to do is we know that the same thing is f of x. Y is the same thing of f of x. We know that in general. This is function notation. So I'm going to rewrite the equation in terms of y, because y is the same thing as f of x. So y equals negative 1/3 x plus 11. All right, we're going to switch variables, because when you deal with the inverse, the domain and the range switch. All right, so we have to switch x and y. So step 2, switch domain and range. So switch x and y. So let's do that. All right, so x is equal to negative 1/3 y plus 11, because the domain and range switch for the inverse. And then you're going to solve for the original variable, okay? So the second step here, actually let me put it in red. All right, so step 1, we switch variables. Step 2 basically is you solve for y, the original variable. Okay, so let's do it. All right, I'm going to subtract 11, so x minus 11 is equal to negative 1/3 y. Okay, piece of cake. All right, and then you have to multiply both sides by negative 3. So I'm going to do that. So negative 3 times the other side, both sides here. Okay, gives you y, and that gives you the inverse. So this is the inverse, and so what we need to do is write it in inverse notation. So F inverse, or, well, you can say it two ways. I'm going to write it two ways, so because there are two ways to do this. So Y inverse, okay, is equal to -3. I'm going to distribute through the -3 here. So -3x plus -3 times -11 is 33. The other customary way to write it is F inverse of x, okay, F inverse. Remember, we don't say to the power of -1, okay, that is not the way we do it. Okay, we say F inverse, so this notation right here, just to remember, is called F inverse, or the inverse of F, but usually people just say F inverse to make it simple. Okay, so F inverse is -3x plus 33. All right. There we go. That's it. Number 3, a table of selected values is given for a one-to-one function. What's true? What's true, or not what's true, excuse me. What is G inverse of 1? Okay. Well, let's understand something here. From the table here, I know, let's take a look at the only y value here in this table is 8, 1. All right, where when x is 8, y is 1, or g of 8 is 1. So I'm going to take a look at this right here. So this right here tells me that g of 8, all right, is equal to 1. Well, that tells me that g inverse of 1, all right, equals 8. That I know. Because remember, what a function does conceptually here, so if I draw a little mapping diagram here, actually it's too small, so okay, let's say this represents the domain, and over here we got the range. Okay, size doesn't matter here. I shouldn't have drawn it, you know, it's a bubble, it's a set. Okay, so over here domain is x, range is y here, and our function's g, so g maps whatever's in the domain to the range. And so 8 is in the domain. Okay, it's an input value. Remember, domain is input, range, output. Okay, so when x is 8, you send it through the function g, you get 1 over here. So g of 8 equals 1. But remember, conceptually speaking, right here, the inverse, we'll call it g inverse in this case, takes 1, all right, the output of the original function, which now becomes the input of the inverse, and sends it right back to the original value. All right, so the inverse sends the number right back where it came from. That's what the inverse does. And so g of -1 equals 8. All right, so basically the inverse sends it right back to the input value. Okay, number 4. Let m equals f of t here represent the total money earned. So there's a money function for t years. So t is number of years. And this is a money function. All right, so f of t equals money, or f of t equals money, actually. M equals f of t, and that represents money earned, okay, dollars. Explain what information is given to you by the function f inverse. Be sure to include input and output for your explanation. Okay, so let me just say it like this right here. So the function, so f of the years worked. So let me just put it in terms of the words here. All right, it gives you the money earned. Okay, money earned. So this is basically what's going on with the function here. And then what does that tell me? If I take the inverse of this function right here, that tells me that f inverse of the money earned, money earned here, gotta spell it right. Okay, there we go. So if f inverse takes the money earned and sends it right back, all right, to the number of years worked. Okay, so number of years worked. Okay, so now what happens is that the input is now in the inverse. The input is the money earned, and the output is the number of years worked. Okay, That's what the inverse does. This right here is the inverse of the function. All right, so the output, so the original input is the number of years, and then you get the output is the money earned. All right, but for the inverse, it's it's switched. The output becomes the input, and it takes you right back to the original value. Okay, that's what inverse does. It sends the value in the range right back to the domain value. Okay, number 5, if negative 9, 4 is on the graph, which of the following order pairs is on the graph of f inverse. Okay, so remember this is the inverse notation, all right? And you have to remember that for any function here, when you switch from f to f inverse, so let me just write it this way. So if any point, call it x comma y, is on the graph of f, I think this will make more sense. Okay, then if you switch the domain and range, then y comma x right here is on the graph of f inverse. Okay. You should have graphed these things in the previous courses, okay? So hopefully this is like ringing a bell from Algebra 2, because when I teach Algebra 2, it's like I actually plot points and we reflect them across y equals x, and we get the inverse, because inverse functions are reflections across the line y equals x. And the only thing that happens is that the coordinates switch, okay? So basically the coordinates switch. All right. So if you're given a point negative 9, 4, when you switch coordinates, it becomes 4, negative 9. So it looks like this one right through here. Okay, and that was the main idea. So again, I put all the main ideas in red in my lessons and everything, so you might want to focus in on that. We're skipping 6 and 7 here, so let's just go right to 8, and then we are done. This is actually a shorter homework assignment. Finally. I know you guys are going, thank you, God. Okay. All right, so now find G inverse. Okay, so remember, this is the inverse notation right here. And so what I do is I just rewrite it in normal notation, because we know that this is the same thing as y. So y is equal to 2x minus 6. Okay, switch variables, so x is equal to the square root of 2y minus 6. And at this point, you just solve for the original variable, so solve for y, so I'm going to square both sides. And what you get is 2y minus 6 equals x squared. You got to square both sides. Okay, and then you got to solve for y. So I'm going to add 6. Come up here, I get x squared plus 6 is equal to 2y. And then you just divide by 2 and you're done. So you get y. I'm going to switch the sides just to make it look kind of normal, okay? And so this becomes the inverse here, and so it's actually G inverse, not F inverse. So I'm going to write it in inverse notation. So G inverse of x is equal to x squared plus 6 divided by 2. And if you want to write it as x squared divided by 2 plus 3, you can do that as well. Just divide both by 2. All right, now use compositions right here to verify that G and G inverse are in fact inverses. Okay, so here we go. I have to show that G of G inverse of x is equals x. Okay, so here we go. And then I have to do it the other way around as well. So I start off with G of G inverse. So I got to substitute in G inverse and G. I got to substitute this way, starting with the inner function right here. So I'm going to do that. So if my function G here is the square root function. So it's 2 times whatever x is minus 6. So I substitute in the inverse, which is x squared plus 6 divided by 2. So notice that I just substitute in the inverse into G. Do a little simplifying. All right. Simplifying, let me see, 2 divided by 2 is typically 1. All right, especially in the morning here, and it is in the morning, and I get x squared plus 6 minus 6. That gives me the square root of x squared, and that gives me x. Okay, so this one's good. Okay, you had to show that when you substitute the inverse in the original function, you get the original variable. And the reason why is because the inverse sends the range value right back to the original value, which is x. That's why you always get x when you substitute an inverse into the function, or vice versa, because it sends it right back to the original value every single time, right? Like I said in the previous problems here, when I drew these mapping diagrams right here, like in number 3, look here, all right? A function takes an input, sends it to the range, gives it an output of 1, so g of 8 is 1. What does the inverse do? It sends it right back to the original value. All right, and that's what an inverse does. It sends it right back to the original value, which is called x in general. All right, and that's why when we write these definitions for inverses, that's why they make sense, okay? Now, you have to show the other way. So you have to do 2 things. So show that g inverse, okay, of g is also x. Okay, so now I'm going to substitute g and g inverse. I'm going to do it the other way. Okay, so I got to take g now, which is up here at the top, and I got to substitute it in g inverse, right through here. Okay, so here we go. So I start off with my notation. So g inverse of g here is equal to, all right, it's equal to something squared plus 6 all divided by 2. That's g inverse. Now I'm going to take g and substitute that in. Okay, now g is the square root of 2x minus 6. So notice that I substituted in g here in g inverse. Okay, when you square root, the operations cancel. The square cancels out the root, giving you in the numerator just 2x minus 6 plus 6, all divided by 2. That gives you 2x divided by 2, which is x. And so this is also checking out fine. And when you substitute the one function into its inverse, or vice versa, if you get x both times, then that tells you they are inverses. So this tells me right here, the conclusion right now, come on, there you go. Okay, F, okay, not F, we're dealing with G, sorry. All right, so G, okay, and G inverse are inverses. That's what it tells me, all right, because I did both substitutions. I ended up with x on both cases here, and if that happens, you just proved, okay, not verified, you just proved that the functions are in fact inverses. And this is an important one, so make sure you do this one. And make sure you understand it really well. These are key essential problems, okay? Key problem. So make sure you study it, make sure you understand it fully, all right? And I'll see you guys in class. This is Ainsworth. See you next time.